Welcome to Microsoft Build 2017. Today we're going to be talking about advanced cross-platform mobile applications for iOS, Android, Windows, all powered by Azure mobile apps and Xamarin. I'm James Montemagno. I'm a Principal Program Manager on the Mobile Developer Tools team here at Microsoft. You can find me anytime on Twitter, my blog, or just email me, motts@microsoft.com. If you love what I hear, there's even more great content right here on Channel 9, on The Xamarin Show, and a podcast I do called Merge Conflict. We're not here to talk about me. We're here to talk about beautiful native cross-platform apps with Xamarin. So what is native? What does it mean to create a native application? Well, to me, I've been a .NET developer for over a decade and a mobile developer for the last 7 years. And what I've boiled it down to, what we need to deliver to our users and what we want as developers are 3 important things. To create a native app, you need a great native user interface. There's a reason someone bought an iOS, Android, or Windows device. They like the hardware, but they also love the software. So we want access to every single control. And as developers, we want access to every single native API to really set our application apart in the App Store. And then finally, they have to be super performant. When you click on a button, you just want it to react immediately. So you get access to all the native UI, API, and performance. So when you want to talk about cross-platform, we want all 3 things. And that's where Xamarin comes in with our unique approach to mobile development, enabling you to build all of your iOS, Android, Mac, and Windows applications all in C# with beautiful C# features, having access to 100% of the APIs, and sharing a bulk of your business logic. So your models, view models, RESTful service calls, SQL databases, things are the same. But you can still craft out beautiful user interfaces for each platform and get native performance. Now, when you build out the user interface, we have 2 approaches. Xamarin Native, building on a native iOS storyboard, Android XML, and XAML for any of your Windows applications, but tying in that shared C# business logic. So that really gives you the high fidelity applications, access to every single UI component, anything that you possibly need. But if you're building an application, you want to go even further in shared code, maybe you want to share some of the UI layer, but not lose that native goodness, that's where Xamarin Forms comes in. With a cross-platform user interface abstraction, you build one XAML, but still get native controls on each platform. But it is an abstraction, so it's the common controls and elements. Things that are really good, like conference applications or forms over data types applications. There's tons of great applications that have been built with Xamarin Forms today. And it just sits on top of Xamarin Native, as you would expect to build out these native applications. Now, how does that work? Well, if you're a Windows developer, you have all of .NET available to you. And for a long time, that's been restricted to just a Windows machine. So you'd get .NET, install it, or be bundled into your application. And then when you want to go and develop for maybe ASP.NET or UWP, you download an SDK and you get some great namespaces associated with that application. Think of it exactly the same when you want to go to iOS or Android with Xamarin. You get all of that .NET goodness running on there with the .NET runtime optimized for iOS, but you get 100% API coverage for every single API inside of iOS. And the same for Android. You get all of the Android namespaces and all of that .NET goodness right there. But we don't stop there, because what we do is we add advanced C# features like async await, lambdas, events, delegates. So even though you're accessing a native API, you're still doing it all in C# with beautiful C# features. And this enables you to build a shared business logic layer. Our average is 60 to 70% code sharing with Xamarin Native, and all the way up to nearly 95% with Xamarin Forms in that shared UI. We still get that native performance. So what we do on iOS is we do a full ahead of time compilation. Compile your C# code and down into IL, one more time into LLVM bytecode, and then finally send that through an LLVM compiler and optimizer to get a beautiful native ARM binary. So to your users, there's no difference. They just go to the App Store, hit download, and boom, you have a great application on your device. In fact, you probably have tons of Xamarin applications already installed on your phone. Now you can use Visual Studio either on the PC or on Mac to develop Xamarin applications, including the Community Edition. Everything in Xamarin is free in the Community Edition. So truly anything that you can do in Objective-C, Swift, or Java, you can do it in C# with Xamarin inside of Visual Studio. So let me show you just how easy it is to get started, not only installing Xamarin for Visual Studio, but creating your first application and deploying it to some emulators. So here I am on my Windows machine. And I've pulled up just kind of the modification screen for Visual Studio. So when you go to install it, and I have my UWP workloads, I have my .NET workloads installed. As I scroll down, you can see I have some other ones, including mobile.net. That's going to give you all of your iOS, Android, and Mac, everything that you need for Visual Studio. So as long as you have that checked, it's going to install all of the dependencies and SDKs that you need. So with Visual Studio open, I can just say File New Project. That will bring up all the different projects that you've been used to, so UWP for instance. But with Xamarin, you have Android, so all of your high-fidelity Android standalone apps, iOS including Apple Watch, extensions, and iPhone and iPad applications, and even Apple tvOS applications. So if you want to create a TV application, you're good to go. We made it really easy to get started with a cross-platform app. So under cross-platform, you're going to find some cross-platform templates. Here, I can say cross-platform app, and I can choose between a blank application using either Xamarin Forms or Xamarin Native User Interfaces. So let me go ahead and check that right here. Then I can select between shared projects or PCLs to share my code. And it'll kind of scaffold out a core project and also my shared code. And here it's going to go ahead and just scaffold out my iOS, Android, and my shared code project. And then at any time, I can add any additional Windows applications such as UWP, older Windows Phone, WPF, you name it, we can add it there. So let me go ahead and zoom in here really quick. You can see that I have my portable class library, and I still have an Android and iOS application. Android with all my resources, Android XMLs inside of there. So I can actually write Android-specific code, add my Android-specific resources, and actually build out my platform-specific code. Same thing on iOS. I have an iOS storyboard file. I have all my iOS-specific code and all my references, including .NET references, NuGet packages, and everything like that. There's my portable class library. So I start building out shared code. So I put my models, view models, maybe Azure integrations, anything .NET related right there. Now I've double tapped on that main Android XML, which is going to be the main screen here. So when I pull up my toolbox, you can see I already have all of my Android widgets there. And this just gives me a simple page, and I can drag and drop controls to and from, including any of the advanced support library packages. And what this is showing you is just the Android XML. So here's a button that I can click on, and then I can access it in the code behind. Now when I installed Visual Studio, I also got some emulators. So here I just hit the debug menu. I can instantly hit debug, and this will spin it up on an Android Hyper-V or an Android emulator. It can be Hyper-V powered or Intel powered here to give you a really fast deployment. So when I hit debug, it'll go ahead and compile up the application fully right on my actual Windows machine and deploy it right here. That's a simple application because it was a blank application. So I can simply go ahead and see it says hello world. I can flip over to the main activity, and here's a button click handler here. I can simply add a breakpoint if I want to, or I could just go ahead and hit click there. There we go. Let's go ahead and hit breakpoint so you can see the full IntelliSense here. Hit click, hit that breakpoint, and I'm debugging my first Android application written in C# with Xamarin in under a minute or two. It's really awesome. Now let's say I want to go ahead and do that for iOS. I could open that storyboard file. I could go ahead and modify it, but I'm just going to set it as the startup. And I'm going to make sure that I'm connected to my Mac, which is my build host, which is sitting over here. And when I do that, it'll reach out, find any devices or simulators that are actually installed on that machine. And all I have to do is hit debug. Here I have Visual Studio Enterprise. So when I hit debug, it'll actually go out and spin up a remote iOS simulator for Windows, enabling full fidelity iOS simulator right on your Windows machine. Now I am connected here to my Mac, so it's going to do a full debug session, compile up fully my application. But here's that same exact application with a button click handler launching fully on my Surface machine right here. So click, 5 clicks, and it's awesome. I could go further, modify any code. If I need to, stop debugging and modify anything I need. And I've created it here in just a few seconds. So let's talk about what else I want to do with my applications. Because while it's easy to just do a file new, we know that every great application needs a great backend. And you need to handle scenarios like online-offline data synchronization. I was just in Cuba a week and a half ago where I lived off of 1 hour of internet for over a week. I bought a little Wi-Fi card, and that's all I had. When I'm on the top of the mountains and I'm climbing around, I have no internet access. But I still want to have access to all my information, like when is my next flight? Let me check my emails, or even past Twitter things that I've actually downloaded offline. So having the ability to do online-offline data synchronization is extremely important. And we have an amazing infrastructure for you to use, which is Azure, with hundreds of data centers where you can deploy your code into over 38 compute regions, more than AWS and Google Cloud combined. And inside of Azure lives Azure Mobile Apps, part of App Service. It's an extremely powerful backend that you can add into your mobile applications. It's flexible. You can use a Node.js backend or an ASP.NET or .NET Core backend for your applications. It has an open source cross-platform client SDK for iOS, Android, and Windows, and an open source C# backend client as well. So you can see exactly what the applications and the logics are all doing. And it works a little bit like this. You install into your Xamarin and Windows applications an SDK that's cross-platform. And there's a RESTful API that lays between your applications and your backend service codes, where it does your data connections to SQL Azure or user authentication or even push notifications. But it handles all this through a seamless API and even does online-offline data synchronization automatically for you, storing it in a local SQLite database. And you can, of course, leverage and deploy your backend code wherever you want. So let's take a look at how you can get started with that in just a few button clicks. So I'm back over inside of Visual Studio, and I would do my File New Project. And last time I did the blank application, but let me go back into cross-platform mobile apps. We made it drop dead simple to give you a great getting started point to set up a master detail application. So before I select a blank app, I'm going to select a master detail. I'm going to select Xamarin Forms this time. When I do Xamarin Forms, I can still select between shared projects or code, and I can hit this really important host in the cloud, which will set up a full ASP.NET backend for my application, including all of the Azure Mobile Apps SDKs for the client apps and the backend, and all the code needed. Even better, when I spin up this application, it'll allow me to deploy that application immediately right from Visual Studio. So here I can actually set a subscription, hit create, and it'll do everything for me. I've already done one ahead of time just to save a little bit of time. So here's this My Items application that I've created. I still have some backend code here. So there's the ASP.NET backend with all my controllers and all the SDKs installed that I possibly need. It's just a standard ASP.NET application. I still have my Windows, Android, and iOS apps, of course, so I can actually write my code there. But this is a Xamarin Forms application, so a bulk of my application is all right here. So I have items, and I'm adding some other workout things inside of here. I have all my view models and all my views right inside of my shared code. So for instance, since this is Xamarin Forms, I have this new item page where I have a label, some entries, and I want to add some items into a list. And this is a single XAML that I share between all three applications. So let me just show you what the app looks like. Here I have a simple, the simple application, has some tabs, so I can have some material tabs over here. I can go ahead and add a new item. Here we go. I can say, hello from iOS, for instance, here. That way you kind of know where it's coming from. And you can see that Xamarin Forms lays on the native controls. So I have the native controls. Here it is. I've saved it. I can pull to refresh natively over on Android, and boom. It's gone ahead and synchronized it automatically with my actual backend code. I can add a new one here, and we can see at the very top now, it's done a full round trip, and it's done a full online-offline data synchronization. I get beautiful material tabs and Android and iOS tabs over there. What's nice is that I can show you the actual Azure code. It's very simple code to do authentication and to do online-offline data synchronization. I simply set up what URL I want to connect to, define my local apps are on the device, and any of my tables. So here I can say, let me just initialize and pull to refresh. And I can even use link to immediately query that local SQL database and get an item and use link to query the ID. If I want to insert an item, I insert it asynchronously and insert it into the database. In under 100 lines of code, I've done full online-offline data synchronization for this app, and I even handle authentication for Twitter, for Azure AD, or anything else that I possibly need. Now, there's a lot more with Azure mobile applications and other services that you want to integrate into your application, and push notifications is one of those. And Notification Hub specifically handles the mess of push notifications across different applications. Normally, you have a notification service like Google notifications or Apple push notifications or Microsoft push notifications. You send handles back and forth and you have a backend. What's great here is with Azure mobile apps, you can integrate Notification Hub into both your client application and your backend app. And it will handle automatically all of the token management that your application needs. Even better is that it does more than just table storage. Azure mobile apps can do push notifications and do full file synchronization to Azure storage. Handle all of your SAS tokens and everything that you need in just a few lines of code. We have a great sample called Contoso Moments that you can download from GitHub or from the app stores to try out for yourself. It does full storage, online-offline sync, user authentication with Facebook and Azure AD, and push notifications. It's a great quick start to get you up and running. Let me show you what that looks like really quick. I'm going to go ahead and set up my actual iPhone device and screen mirror it here. What's cool is that this actually has a website associated with it, so I'm just screen mirroring my actual iOS device here. I'm going to go ahead and log in with Facebook. So I'll go ahead and log in with my Facebook application. It's going to go ahead and pull up and confirm my login. And I've already created a gallery here, and this is that simple kind of table. But I've added some podcasts that I do here and some artwork, so I can kind of keep this at any time. What's cool here is that I can go ahead and say, let me add something here, and I've taken a photo, and I can upload it and do some synchronization to push it up automatically to my backend. So I've added to this gallery, and there it is, a photo of my actual Surface Book here. Over on the website, I can log in with Facebook as well. There's my album that's been set up for me. And here's all of those images that I've just synchronized automatically from my iPhone device to the Contoso Moments backend. So no matter where you're at, I can view different image sizes in both the browser and phone because the image has actually been resized automatically with an Azure function. I can delete this image, I can go back, pull to refresh, and just like that, it's automatically pulled down and synchronized between not only my iOS and my website, but also my Android and my Windows application. Let's look at that code. Here's an image, and it's a simple album ID and user ID, and I have a mobile service file. That's going to give me URLs and any path that I need. I can go out and, of course, query those albums, which will then return a list of items to me, and here are those images. So from the image table, I can go ahead and pull down those images and simply load up those file paths for each image on the system. When I want to take a photo, I just create a new media picker and then simply pull it into my application. And it's just as easy to push and pull those files down. I push any of my file changes, synchronize it, and pull back the data for all of my tables in the application. That's it. This full application is available on GitHub that you can pull down today and get started with Contoso Moments. So what we've seen is how easy it is to not only get started with Xamarin to build beautiful cross-platform native applications for iOS, Android, Mac, and Windows, all from C#, but also how to add a very powerful Azure backend in just a few lines of code to do full online, offline data synchronization so your users can use it anywhere in the world. Contoso Moments shows you how to use push notifications, online, offline file storage, and a whole lot more, so check that out. You can get started today by going to azure.com/Xamarin to learn more about integrating Xamarin and Azure together. And of course, get live and interactive mobile training with Xamarin University. And of course, check back for all the great build videos right here on Channel 9. And be sure to check out my show right here on Channel 9 called The Xamarin Show. Go to xamarinshow.com for all of the Xamarin goodness that you could possibly handle. And with that, enjoy Build 2017. I'm James Montemagno, and I hope to hear from you and see you soon.